Again, welcome to Data Science Using R. This is Unit 14, Association Rules. Also, this unit covers data mining course. Association rule is one of the popular data mining algorithms. So what are association rules? Here we see a study of what goes with what. Again, what goes with what. So an example would be in a supermarket or a retail store, customers who bought item X also bought item Y. So our goal here is we want to know the possibility that if a customer buy item X, he also buy item Y. This will help the store management maybe to put one item on sale and the other item not on sale, since they know when a customer buy X, the probability of buying Y is very high. So we are not going to put the two items on sale at the same time. Or maybe we put one item X very far away from item Y, so that when a customer come to the store, he can maybe, when he choose the item X, he can walk around the store, look at other items before he reaches the item Y. So another example is what symptoms go with what diagnosis. So again, association rules can be based on transactions or events. Also called a market basket analysis or affinity analysis. This is again originated study of customer transaction basis to determine associations among items purchased, which is our first example. Customers who purchase one item may purchase another item. So applications can be a basket data. In terms of basket data, we are dealing with a transaction database system. So here we say market basket analysis, given a database of a customer transactions where each transaction is a set of items. Now the goal is to find group of items which are frequently purchased together. So when a customer purchases banana, what is the probability that it will purchase orange also, or pineapple? And also this concept is used in Amazon. For example, you go online on Amazon, when you put an item into your shopping cart, you see that the system will recommend another item. And the chance that the item may go with the first item will be very high, again, because the algorithm has already studied customer previous purchases, that most customers, when they purchase item A, they also purchase B. So the algorithm was able to give you the recommendation, which is the association rule algorithm, give you the recommendation that since you put an item A in your shopping cart, most likely you are going to buy item B. So this is an example used in the recommendation engines. A very good example also is Amazon or any online transactions. When I purchase item, let's say a textbook, in data mining, most likely Amazon will give me a recommendation to buy a Python textbook, because most customers who buy a data mining textbook also end up buying the Python textbook to study the two together. So again, association rule algorithm is used in recommendations engines also. So let's start with the introduction to association rules. Here, as we said earlier, the goal is to find association among items, or in this case, we can say among attributes. So here we say seek to uncover associations among the variables or items. So of the following form, again, association rule will be in the form of if-then rules. So if antecedent, then consequent. So example is if customer buy beer, then he buy a diaper. Or if customer buy X, then he buy Y. Along with the support and confidence of the rule. So the support and the confidence of the rule, again, we will go through that in a few minutes, is what we normally use to measure the usefulness of the rule. So if the confidence is very high, it will be 1 or 100%, which means the rule is very strong. If the confidence is 0, and that means the rule is very weak, it's not good. And normally we are going to have a threshold value, a default value for both support and confidence. So for example, if in our algorithm, we designed a system that, okay, the minimum support should be 5 and the confidence should be 0.4. This means if we have any rule that is less than 0.4 or 5 for support, less than that, we are going to ignore that rule. And that's the concept of the apron algorithm, which is part of association rule concept. And we may go through that in a few minutes. So example is given here of 1,000 customers, 200 bought diapers. Now of the 200, 50 bought beer. So what is the association rules between diapers and beer? So here we said that if buy diapers, then buy beer. So the support will be what? The percentage of customers that buy diapers and also beer in the whole transaction database system. I'll say the proportion or the percentage. So this means we have only 50 customers that buy diapers and beer. And we have in the database system, total customers is 1,000 customers. So our support will be 50 divided by 1,000, which will give us 5% or 0.05. Now the confidence will normally be all the customers that buy diapers and also buy beer divided by all the customers that buy diapers. So customers that buy diapers and beer together is 50. And customers that buy diapers and other items or only diapers and also with beer is 200. Because the question said out of 1,000 customers, 200 bought diapers. Of the 200 that bought diapers, 50 bought beer. So our confidence should be the total number of customers that buy both diapers and beer divided by the total customers that buy diapers. At least diapers with beer or other items or only diapers. So that gives us 0.25 or 25%. As we said earlier, confidence can never be more than 1. The same thing applies to the support. Also, it cannot, because we are the support normally we divide by the total transaction, or in this case, total customers. So the support and the confidence values is between 0 to 1 or from 0 to 100%. So when I said 5, I mean 5%. When I said 20, then I mean 20%, or I may say 0.2. So one thing we have is the case of dimensionality. What we mean by dimensionality is that, again, we may have so many attributes. In data mining algorithm, when we use the term case of dimensionality, means, again, we are doing analysis, but in this, the data set have high dimension, large number of attributes. So with association rule, when we have a large number of attributes, we are going to generate many rules, more rules. And most of the rules are not very weak. They are not strong rules. So this is where the apron algorithm will come in. In general, the association rule, when we have a very high dimension data set, again, there will be a lot of rules, generate so many rules, and it will consume a lot of time. And also, actually, the term is consume the computer resources, which is the memory and also the speed. So here we say the number of possible association rule grows exponentially when the attributes, or in this case, the items are so many. Here we have only 2 items, diapers and beer. But if we have more than 2 items, and the rules should be so many. So If the two items is diapers and beer, and our attribute is binary attribute, that means the outcome can be 2. This means we are going to have 2 to the power k. Now, if we have 1,000 items, then 2 to the power 1,000, which will be over a billion. So a typical application is market basket analysis. There may be thousands of binary attributes. So this will generate a lot of gain rules. So the APROM algorithm for mining association rules reduces the search to a manageable size. That's reducing the rules that are going to be generated to a manageable size. So we have an example of association rule mining here. Here, for example, we have a local farmer that sells I. We will say the I represent the items he's selling, the total items. So here he's selling beans, asparagus, broccoli, corn, green peppers, squash, tomatoes. So that will be around 7 items. 1, 2, 3, 4, 5, 6, 7, 8 items. Now, customers purchase various subset of I. So a subset of I means we can purchase, instead of 8 items, we can purchase only 1 of them, or 2 or 3 or any amount. But of course, it can't be more than 8. Then D is the set of transactions. Each transaction T represents a set of items contained in I. So each transaction, and the items will be all the items in I, because these are all the possible items the farmer is selling. And this is represented in our table here. So here we have 14 transactions. For example, the first transaction, the customer buy broccoli, green peppers, and corn. But the third customer buy corn, tomatoes, beans, and squash. Then we have a customer that buy only 1, let's say customer number 10 buy 2 items, beans and corn. So this again, 14 transaction. So we want to generate our rules from here, which the association rule basically means, for example, if a customer buy broccoli, what is the probability that he will buy corn or any item? So the association rule takes the form of, if customer buy broccoli, then corn buys corn. So if A, then B, where the antecedent A, and also the A is called the antecedent and B is called the consequent, B are proper subset of I. Remember, we say the I is all the items, 8 items we have. And A and B are mutually exclusive, which means A and B cannot be the same item. So for example, we can say that if a customer buy beans and corn and green peppers, then he will buy tomatoes and beans and green pepper. That's wrong, because we have green peppers in A and we have green peppers in B. A and B must be mutually exclusive, which means we can say, okay, if a customer buy broccoli, corn, and green pepper, then he buys beans and tomatoes. That is good, because A and B are both mutually exclusive. So now we know what association rules look like, if-then rules. Now, how do we generate the rules? First of all, we need to measure the rule, as we said earlier, with a support, confidence, and also a lift. So a support will tell us how, or I'll say the percentage, the total percentage of the transaction in the database. And the confidence is very good. Actually, that's the meaning of the word confidence. It gives us the confidence of the rule that was generated. So normally the confidence, as we said earlier, the confidence value will be 0 to 1. If it's 0, it means you have a low confidence. The rule is very weak. If it's 1, then you have a very high confidence. The rule is, then if it's 0.5, 0.6, etc., is between weak and also strong. So support and confidence are the two most important metrics or measurements that we use for our association, again, rules. So for example, we set our minimum threshold for support to be 0.2. Now, if I generate a rule and I find the support and the support was less than 0.2, that means the rule is not good. It's a weak rule. And we will talk about this again when we cover the APROM algorithm. So here, support, confidence, and lift. We say the measures of goodness of association rule include the support, confidence, and lift. So the measures of goodness of their rules, association rule, is knowing the support, confidence, and lift. So the support for a particular association rule is the proportion of the transaction in the database system that contain both A and B. We said if it's A, then B. And the support will be the proportion, or I will use the term also the percentage, because normally we can see the formula here for support. It will be the number of transactions that contain both A and B, because if a customer buy A, then he buy B. So the number of transactions contain both A and B divided by the total number of transactions in the database system. It doesn't matter whether the transaction have A, have B, or it doesn't have A, it doesn't have. It's all the total number of transactions. That's why we say the proportion or the percentage of transaction that we have A and B. So again, we're going to see an example in a few seconds, a minute. So a confidence of association rule is a measure of accuracy, the confidence of the rule, accuracy of the rule as determined by the percentage of transaction in D. So it contains A that also contains B. In other words, confidence will be the probability of B given A is equal to probability of A intersect B divided by probability of A. Now, the concept is very straightforward. We have the rule that if a customer buy A, he also buy B. So the confidence will be how many transactions that customers buy A and B divided by how many transactions that the customer buy only A. And that is when the customer buy A and B, it will be A intersect B means we have both A and B together. Then divided by only A will be probability of A. So that's the translation here, the number of transactions containing both A and B divided by the number of transactions containing A. So in the language of probability, confidence represents the conditional probability of B given A. And with the support, the number of transactions containing both A and B, but divided by the total number of transactions. So again, this is our database. Again, we have 14 transactions. Each transaction customer buy different items. So we are going to use that as an example. So we consider that if customer buys squash, then he also buy beans. So A represents squash and B represents beans. When we look at our table, we have 7 transactions where squash was bought. And also we have 6 transactions where beans were also bought. So this means we are going to have 6 divided, the total transaction is 14. So first, our rule said, if customer buys squash, then buy beans. So we are going to look for squash and beans, which is beans and squash 1, and 2 for customer 6, and we have 3, customer 9, we have 4, customer 11, 5, customer 12, and squash and beans 6, customer 13. So 13 customers or 13 transactions have both squash and beans, but the total transaction is 14. So to find the support, we divide 6 by 14. which gives us 0.429 or 42.9%. Then we are going to find the confidence. We already know the number of A and B. Squash and beans together is 6, so I'll put the 6 down. But now we are going to count how many. Remember the A, the antecedent in this case is squash. So I'm going to look for how many squash I have in the database, which should be 7. Now, if we have another example saying that when a customer buys beans, he also buys squash, the confidence can change because this time it's going to be instead of B by A to be A giving B instead of B giving A. But support will be the same because support means A and B. So A intersect B, A and B together, whether it's B and A together or A and B, it's the same amount. So support will be the same. So let's say if we have a 7 squash, let's go back. So we have 1 customer number 2, 2 customer number 3, 3 customer number 6, 4 customer number 9, 5 customer number 11, 6 customer number 12, and 7 customer number 13. The last one, we don't have no squash. So that's correct, 7. So the confidence will be 6 divided by 7, which is 85.7%, which is very good, almost 0.87, almost close to 1. So now, based on our minimal threshold for support and confidence, we can say whether the rule should be accepted or not. So maybe if our support was 0.3 and our confidence was 0.5, then our rule will be accepted. It's a strong rule. So we have another database here. Again, it's the same database, but the customers have been reduced. So we're going to use this as an example here. So again, a lift will compare the confidence in rule to probability of choosing the consequent at random. A lift always compares the confidence in a rule to the probability of choosing the consequent at random. So lift will be the rule confidence divided by the prior proportion of the consequent. So we should recall the example. We have 1,000 customers, 200 bought diapers, and of the 200 customers, 50 also bought beer. Now we say that if 100 of the 1,000 customers bought beer, prior proportion buying beer is to be 100 by 1,000. Because here we have 1,000 customers, 200 bought diapers, and of the 200, 50 also bought beer. Now we have a condition saying that if 100 of the 1,000 customers bought beer, then the prior proportion buying beer is this, 100 by 1,000. So the confidence still will be 50 because confidence is the customers, not here the 100 customers that buy the beer, not all of them also buy diapers. But we know that 50, and those who buy diapers, the 250 of them buy beer. So the 50 here represent those who buy diapers and beer. But the 100 here represent only those who buy the beer. So our confidence for our rule will be 50 by 200. Because the diapers, if you buy diapers, then you buy beer, will be 50 over 200. Now, to find the lift, it will be the rule confidence, which is 0.25, divided by the prior proportion. How many people bought? You see, the consequent is the beer. So that will say the prior proportion of the consequent will give us the lift. So the consequent, which is the beer, the total customers who buy beer is 100. but out of the 100, 50 who buy beer also buy diapers. So that's why we have A and B is 50, or diapers and beer is 50, but only beer is 100. So the prior proportion of the consequent will be 0.10, which will give us 2.5. So here we can interpret the lift to say that customers who buy diapers are 2.5 times as likely to buy beer as customers from the entire data set. So that would be again the interpretation of the lift value. Again, the whole concept of lift is the rule confidence divided by the prior proportion of the consequent. So if my confidence is here, we say if customer buy diapers, he also buy beer. So the prior proportion of consequent will be the beer. And here they tell us out of the 1,000, 100 buy beer. So that would be the 10% or 0.1, the prior proportion of consequent. So now we go to the second example. If customer buys squash, then they buy beans. If we quite remember, the rule confidence was 6 by 7. The prior proportion of the consequent will change here. So here it's going to be 9 by 14. Why is it 9 by 14? Because again, in this rule, we are looking for the proportion of people who buy only beans, because our consequence, we say if you buy squash, which will be antecedent, then buy beans, which will be the consequence. So the number of beans we find from the data set, which are 14 transactions, was 9. So the proportion of that will be 9 by 14. And that gives us 1.33. So we can make our final interpretation of the lift that customers who buy squash are again 33% more likely to buy beans than the general population. So mining association rule, here we say we need to find the baseline proportion for various variables. So for example, the proportion of a customer who churn is 14.53. So this will be a baseline. Now we can generate association rule using the following settings. We need to specify the type of association to obtain as rules. So we have our minimal support equal to 1%. Also, minimal confidence equal to 40%. The maximum number of antecedents is 1. So again, we specify this. Then next, we can delete rules that contain churn in the antecedent. So the association rules with the greatest lift is the first one with rule ID 1. So the lift makes the greatest lift make the rule very strong. So here we say if customer service cost equal to 5, then churn is equal to true. So the lift for rule ID 1 is about 4.06. Again, this example based on a data set. So now we go to the R zone. I think this is the main concept. So we are going to see how we can implement association rule using our program. So the first thing we do, of course, with the R, we need to load our data set. So we are going to read in the adult. Again, the data set name is adult data set. It can be any data set you are using. Then we all know the read.csv. We are getting a file. We want to read the file to a variable named data. So we have read.csv. The directory where the file is located is what is here. So it's in my C drive, users folder, etc. Chapter 8 folder, and the file name up to here. So we have an argument that the string as factors should be true. So the first, again, the first code here is just loading the adult data into our variable that we created called data. And this shouldn't be too, again, it's very long here. I should have made it very short. But again, this is just the directory where the file is, the adult file is. Next step, we need to install and load the required package. In association rule, the package for R is called A rules, everything lowercase. Remember again, R is a case sensitive. So A rules is our package. So we all know the R command to install package. So install.package A rules. Now I'm going to use the library A rules to see. Then next, remember we have our data variable where the file is. So we use the names data. Then we make the factors into a transaction object. So we have a variable name testing as data, and we create our factors here. So the next step is to run the program to view the output. So we need to use the apron. So we are using the apron algorithm. So apron testing, the parameter we need to specify our support. So here the support here is the minimum threshold. So whatever rule that we generate, if the support is greater than or equal to 0.15 of the confidence 0.80, then the mass length also is 3. Then we are going to generate the rule. Then the last step is just to inspect the rule, and we'll see all the rules. So again, this is the R for implementation of the association rule. Most important thing here, we should know the package name, which is the A rules. A rules is the package, and it also contains the apron algorithm. And if we want to use the apron, then we just write the apron with the argument. The argument, we need to specify our confidence and the support, the mass length, using the list. So the output will look something like this. When we click on inspect rules, it will show us all the rules that were generated. Again, in my next lectures, I'm going to, again, run this program as a hands-on when we start the R. At the moment, we're still doing the waker in our class, so we'll start using R. Also, we have the waker video already for association rule, which is in the classroom now. So again, wish everybody the best, and thank you for your time.